Hello everyone. Quick little video to share a cool little integral that I came across on Facebook this week. Somebody in a group that I'm in shared this integral, which is what is the integral from 0 to 1 of the inverse tan of x over 1 minus x dx. Now, obviously, when we see a trig function like an inverse tan, we're kind of thinking triangle. So the first thing that I did is, well, what's the angle that has a tan x over 1 minus x? It's going to be x there, 1 minus x. And then if you calculate the hypotenuse, it's going to be the square root of 2x squared minus 2x plus 1. Which doesn't look particularly useful. But often on this type of where you have an x and a 1 minus x and you're going from 0 to 1, if you look at the first half and the second half, there's some kind of symmetry. So if we split this into an integral from 0 to a half of tan inverse x over 1 minus x dx plus the integral from a half to 1, we can clearly do that. Tan inverse x over 1 minus x dx. Well then, with this kind of split here that we have, we can, on the second part maybe, try this substitution. We go u equals 1 minus x. And then du is equal to minus dx, and x is equal to 1 minus u. So then our integral I, let's say I, becomes, the first part stays the same, the integral from 0 to a half of tan inverse x over 1 minus x dx. And then the second part becomes the integral from, well, when x is equal to a half, u is equal to 1 minus a half, which is a half, so that's fine. That lower bound doesn't change. When x is equal to 1, u is 1 minus x, which becomes 0. Tan inverse of x is equal to 1 minus u over 1 minus x is u. And then instead of dx, we're going to have minus du, which gives us this really nice manipulation that we can do. 0 to a half tan inverse x over 1 minus x dx plus. We can just swap the bounds here and multiply by minus 1. But then we've got this minus in here. So if we swap the bounds, multiply by minus 1, we've got this minus in here. So swapping the bounds and multiplying by minus 1 in here gives us the same thing, right? So we end up with this being the integral from 0 to 1 half of tan inverse. The other thing that I can do is, since everything here is in terms of u, I can swap u for x, and it changes nothing, right? So I can go 1 minus x over x dx. Well, now that we have the same bounds on the integral, we can bring both things inside the integral, right? So we end up with integral from 0 to a half of tan inverse x over 1 minus x plus tan inverse 1 minus x over x dx. And now we can see why this this symmetry is nice, because theta here, the tan inverse of x over 1 minus x, that's theta. And tan inverse of 1 minus x over x, that's pi over 2 minus theta. So when we add them, we just get pi over 2. So this ends up being the integral from 0 to a half of pi over 2 dx, which ends up being equal to pi over 2x evaluated from 0 to 1/2, which equals 1/2 pi over 2 pi over 4. And we are done.